So hi guys, today we are going to solve a problem on CodeShift. The name of the problem is Godfather. The link to the problem is given in the description. Let us see what the problem is. We are given a rooted tree of n vertices, but from 1 to n. The root of the vertex is at number 1. We are given q queries. Each query consists of k distinct integers or k distinct vertices, and we need to identify the Godfather node in that. The definition of Godfather node is given here. So basically a Godfather node is that from every node present in the k distinct vertices, there exists a node in which a unique path from that particular node to the root must consist that node. Like for example, we can understand with the help of this tree. Like in this example 3, 7, 8. The vertices were 3, 7, 8 given to us, then the Godfather node must be 3, because the path from 7 to the root consists of 3. The path of 3 consists of 3, 1. The path of 8 to the root consists of 1, 3, 7, 8, which also consists 3. Therefore 3 is occurring in all the nodes present at the particular query. So the Godfather node will be, and let us take the example of the queries that we are given in the question. So the first query is 3, 7, 9 and 10. 3, 7, 9 and 10. In this query, we can see that the unique path from 3 to the root is this 1 and 3. The unique path of 7 to the root is 1, 3, 7, which also consists 3. The unique path of 9 till the root is 1, 3, 7, 9, which also consists 3. And the unique path from 10 to the root is 1, 3, 7, 9, 10. So it also consists. Hence all the paths from all the vertices that we are given till the root consist of 3. Therefore 3 will be the Godfather node. Let us take another example, that is 5 and 6. So 5 and 6 consist of the paths that are 5 to 1. So one path is this and the another path is 6 to 1. But both of these paths does not contains 5 and 6 at all in all the cases. Therefore there will be no Godfather node in that case. If there was 2 present in the given query list, then q must be the Godfather node, but since it is not present in the query list, then we can say that there is no Godfather node for simply 5 and 6, hence we'll print -1 in that case. This is the definition of Godfather node, and now let us see how we can solve this problem of finding the Godfather node. Basically we can apply the naive approach, that is of O(n) square, of traversing all the nodes and calculating the DFS and finding that whether this particular DFS works or not from that particular small node. But this will take more time. It will take order of v square time for all the vertices, and that is not possible because the constraints are pretty high here. As we can see, n lies from 1 to 2 into 10 to the power 5. We need to think of some other approach. So the approach can be that we can maintain t in t out for a particular node, that is timing when the particular node is traversed in the DFS structure and the timing when the particular node gets out from the DFS structure. So let us see how with the help of an example. This is the tree, and let us see that how we can perform DFS. So first we are starting the DFS from the root node and we are marking the time count as 0. We are incrementing the time count whenever we visits or leaves the node, right? So when we perform DFS on node 2, we go from node 1 to node 2. We'll first mark the node 1 from 0 timer, then we'll increment the timer and mark the incoming t in for node 2 as 1. Then we'll mark the incoming for node 5 as 2. Then when we leave node 5, we'll mark the t out, that is time out, for that particular node as 3. And for each and every node, like for when we are entering this node, we are marking it as 4, then we are leaving it, then we are marking it as 5. So while performing the DFS, we'll get to know that each t and t out for the particular node. For the whole tree, we'll mark it, and after marking it, we'll store in some arrays like that. And what is the benefit of this is, when we are getting the queries, if the particular node is not in the particular subtree of that particular minimum node that we are getting, then we'll print -1, otherwise we'll get to know the minimum node. So we are getting, like for example, let us take the example of this path 3, 7, 9 and 10. So by easily we can say by comparing the t-ins of this particular nodes, that the minimum t-in is of node 3. That means node 3 will be at higher level, and it must be a godfather node if all the other nodes belong to its subtree. And how we can check that all the other nodes belong to the subtree is that we can see the t outs of all the other nodes are less than the t out of this node. So if all the t outs are less than this particular godfather node's t out, then all the nodes belong to its subtree. Otherwise, if any node has a greater t out, then it must lie uh, above this. It must lie. It does not lie in the particular subtree. So by checking this, we can easily find that all the nodes belong to a subtree, and the minimum of that particular node's t in is the godfather node. So this is the approach that we are using here in this present question. Let's try to code this approach in our editor. So let's try to code this approach. First, we are taking the values. We are given the number of nodes and the type of queries. So we'll take n minus 1 edges here in this question. It has been given that it is n minus 1 edges of the tree. Take now what we will do is we'll maintain a adjacency list. Let us make a vector of n nodes, and for each and every n minus 1 edge we are going to put in an adjacency, two variables l and r, and we need to add it into the adjacency list. Why we are maintaining an adjacency list is because adjacency matrix can cause timely related issues, and adjacency list can solve the problem in order of vertices plus edges. So we have taken the input in adjacency list, and now we need to maintain a visited array also. We'll maintain a visited array, the track of visited node. Okay, and now we are going to perform the BFS on these nodes. Let us make a function of BFS which will pass the visited array. First we'll pass the adjacency list, then we'll pass the starting vertex, that is 0. So we have maintained l minus 1 and r minus 1 because indices are given from 1, and we need to take the indices from 0, as I am maintaining an vector of n integers only. So if you want, then you can make a vector of n plus 1 if you are making the indices from 1. I am making the indices from 0. The starting vertex is 0 for me, and now I am passing the visited array, and also we pass a mat array. So I'll tell you what the mat array is. We are storing the value of t in and t out in a two-dimensional array, that is a mat array. The mat array that we are giving, and this is the DFS or BFS function that we are constructing. So let us try to implement the other inputs, and we need to maintain the count of the time, so we'll make a global variable naming count t. Let's with it. Now first of all, what we do in, sorry, it's a DFS, not BFS. We are performing a depth first search. It's a DFS. What we do in DFS is we'll first make the visited of start equals to true equals to, and for I equals to I less than array of start dot size I plus plus as the node as if visited of that particular node is 0, we are going to call the DFS over that, and we'll mark the visited that is now visited. Okay, now we need to maintain the count of these functions also. What we will do is, first we'll, as soon as we get the node, we'll first make the count is assigned to the particular matrix, that is we are maintaining 0 for t in, we are maintaining, assign the count to it. Whenever we get the node, we'll increment the count, then pass to another node, and after that we'll also increment the count and make it for the t out, that is first index. Okay, the whole function, and let us try the remaining part of the code, that is getting the queries. So we have taken the queries function, we have already inputted the queue. Now we need to queries. First we'll take the length of the query, then let's maintain an array, put the vertices that we need to get, we'll reduce the size of vertices as soon as we get it, because the indexing is from 0 in our case and we are getting the indexing from 1, so we reduce it by 1. And now we have also the matrix that we need to construct, and we have also the vertices that we are getting in each query. What we'll do is, firstly we'll try to get the node which has minimum t in value. So basically let us say that the node with minimum t value is like we are initializing an int max variable, we'll update in for each query. So if the value of the of I less than given value, then we'll create the value as particular the matrix, we'll get the id as this is of I. Okay, so we are maintaining a variable id which consists of the node that we are getting, from which we are getting the minimum value, yeah, that particular node in the id. Now we know that which node has the minimum t in value. Now just we need to check that whether all the nodes are present in the particular subtree or not. So for this we'll run one loop. Basically, if the t out values of the all the nodes are less than the t out value of the node of which we are getting the godfather node, that is the id that we are getting, that is the godfather node that we just made now. If these values are less than the godfather node t out values, then we can say that this is the godfather node. Otherwise there is no godfather node. If any of the value comes greater than t out value of particular godfather node is id, then we'll say that id is equal to -2. -2 I'm just writing because I'll explain you, because at last I am printing id plus 1, because the indexing is from 1 and we are taking the indexing from 0, so we need to increment it. And here the id is -2. If the value is not there and there is no godfather node, then we'll increment this. -2 plus 1 becomes -1 and the corresponding result will come as -1. This is the case, and I suppose the whole code is written. So let us see what happens. Run it. Okay, so we are getting the result as desired in the question, that is 3 minus 1 1 1. And let us take another test case also. We are getting the answer as 1. Let's try to submit this code on code. And the question is accepted. This is the problem on depth first search. It is a good problem which consists of simple logic of getting t in and t out value. So subscribe my channel for more such videos. Thank you for watching the video.